sorry about the issues that we had. I got it resolved, so for next week we'll be ready to go. I'm only going to cover 5.4 today because I want to take our time and make sure that we have this material down for you. Now, some of this stuff is just going to be for you to memorize or to have access to. It will be important, okay? Now, in this first example, notice that there's a c there. That's a constant, so what we can do is we can take the constant out and then take the integral of f of x dx. That's important, and again, the dx is telling me what variable I'm taking the integral with respect to. In the next example, notice that it's just the integral of a constant, so what we can end up doing is going pulling the k out like in number 1 and then taking the integral with respect to x, and so what that ends up being would be k times x plus some constant c, because the k is multiplying with the integral, and that's how you get that. Now, number 3 I've shown you before. It's the power rule for integration, and so what we end up doing is we're going to go x to the n plus 1, but then we're going to divide by that power, and then we need to add a constant. Now, the whole point to this section is it's the indefinite integral, and since it's indefinite, this is like the antiderivative where we need to add the c because we don't know if we were to take the derivative, go backwards, what that constant would be. So that's important for you to have and understand. The next one we also did, so that's ln of x plus c. Let's make that a better c. Then sine is negative cosine of x plus c. The integral of cosine is sine of c. Secant squared. So what would give me secant squared? That's tangent, right? If I were to take the derivative of tangent, I'm going to get secant squared. Cosecant squared is a negative cotangent of x plus c. Secant tan, that's secant of x plus c, because the derivative of secant of x is secant tan. Cosecant is negative cosecant of x plus c. Now, something important for you to note, sine is negative, cosine squared is negative, cosecant squared is negative, and cosecant, those guys end up being the negatives. Cosecant, cotangent, cosecant squared, and sine. Okay. Now to get some trigonometric ones. So when you see the integral of 1 over the quantity x squared plus 1, that derivative is going to be tangent inverse of x plus c. And then the rooted one down here, number 12, is going to be sine inverse of x plus c. Those are the ones that you're going to have to know. Okay? Practice these. Have these down, these tools. They're going to be important for you to have and understand. I can't stress how much you'll have to practice these to be able to get them. Now, I'm going to also give you the hyperbolic integrals. You'll use them in Calc probably 3, but the sine hyperbolic of x, the derivative of that is going to be cosine hyperbolic of x plus some constant c, and then cosine is sine hyperbolic of x plus c. These are, they're positive, they don't change signs like sine and cosine would when we take the integral, so that's something that's important. Okay, so in this next example, now we're getting into examples that are going to give us some real practice. And that's what's important. That's what we want to see. So in this example, what I end up seeing is there's 3 parts to it, right? There's the x squared part, there's the constant 1, and then there's this fractional piece here. So I'm going to break this up into 3 different parts. So I'm going to have the integral of x squared dx, the integral of 1 dx, plus the integral of 1 over x squared plus 1 dx. Each one of them has to have the dx, and we have to go through this process. So this first one is going to be by the power rule. So we're going to have to add 1 and then divide by that new power. So I'm going to get x to the third over 3 plus some constant, right? Because it's indefinite, and each indefinite is going to have a c. The integral of 1 dx, well, that's just going to be x plus some c2. And then this 1 over the quantity x squared plus 1, we know that that is tangent inverse of x, and it's going to be having a constant added to it. So that's something that's important to have. Now, one of the important things is when we write this problem out, we're going to get x cubed over 3 plus x plus tangent inverse of x. And then we have these 3 constants. But if we add 3 constants, don't we just get a new constant? And so this ends up being our answer. Because like if I had C1 was 1 and C2 was 2 and C3 was 3, those would end up being a new constant 6, right? So since we don't know what the constant is, we just make it a capital C for some new constant, okay? That's the gist of this, breaking it down for each single one. I want to do another example for you. And so here's the other example. It's going to be the integral of the square root of x cubed plus the cube root of x squared. And this whole quantity is going to be multiplied by dx. So I need to write this as 2 integrals. And so that's what I'm going to do. And it's important that you see the power rule that's happening there. With the first one being a square root, the 2 is in the denominator, and the other one being a cube root makes the 3 go into the denominator. So now when I do the power rule to this, I'm going to get x to the 5 halves, but the reciprocal of 5 halves is 2/5 plus some constant, and then the other one's going to be x to the 5/3, but that's going to give me the reciprocal of that is 3/5 plus some new constant. And so my answer here is going to be 2/5 x squared over 2 plus 3/5 x to the 5/3 plus a new constant, because those 2 constants give me a new constant. And so I get this as my answer. That should make sense. We could clean it up and put it under one denominator, but that's not that big a deal. That's a good enough answer for me. I want to do one more example for you guys, and then that'll be it for... maybe I'll do 2 more examples for you. So this next example is going to be the integral of v times v squared plus 2, that quantity squared dv. So the dv is telling me what I'm taking the integral with respect to. So in order to be able to do this problem, because we still don't know products, I have to expand. So I'm going to go v times v to the 4th plus 4v squared plus 4 dv. And then that's going to become v to the 5th plus 4v to the 3rd plus 4v. All of that is going to be multiplied by dv. So then when we do the power rule, that's going to be v to the 6th over 6 plus c1 plus v to the 4th. So it's 4 over 4 plus some c2, some new constant there, and then 4v squared over 2 plus some new constant there. Now what ends up happening that with that is I'm going to get v to the 6th over 6 plus v to the 4th plus 2v squared plus some new constant. And there is my solution for that one. Now let me do a trig one for you, and then we can call it a day. All right. So this one's going to be the integral of secant of t times the secant of t plus tangent of t, all of that being integrated with respect to t. And so when I do this problem, what I'm going to get is the integral of secant squared of t plus, let me erase that real quick, my apologies, dt plus the integral of secant of t times tangent of t dt. And I know that the integral of secant squared is tangent of t, but I'm going to need a constant. And the integral of secant of t times tangent of t is secant of t plus some constant. And so what ends up happening is I'm going to get tangent of t plus secant of t plus some new constant c, and this will be the result. Now, you can tell with all of these problems, I obviously know what these values are. I have them very much memorized in my head, but it's going to be important that you either make flashcards or something that's going to get you to know at least these first 12, right? I'm not going to do anything with hyperbolics, so the important thing is that you guys have the first 12 of these memorized, or at least have them around handy so that you can use them, because it's going to be coming up quite a bit during these next few, well, at least for the rest of this semester, and guaranteed going into Calc 2. Let me go back to that last problem just so you guys have that for sure. So you guys can have access to that just in case you missed it. Again, my apologies that our live session had some glitches, but here's the video for 5-4. All the best, stay healthy, be safe. Take care.